let's kick things off. Let's talk about Java. Java's cool. Java, what is that? Well, it's two things, sort of. It's first off, it's a programming language. So it's a class-based. We'll get into what class-based means. Um, but it's a class-based, object-oriented, with some functional influences here and there in some newer versions of stuff, programming language. So object-oriented essentially means that rather than dealing with functions and dealing with running functions to like calculate something, we're dealing with objects. We deal with things and then we manipulate those things. That's essentially a very simple way of describing object-oriented programming. You have objects and then you manipulate those objects with one another. The programming language itself, Java, which we'll see a bit of code later, has a lot of inspiration and borrowed syntax from C++. And most importantly, it is unrelated to JavaScript. Java and JavaScript, as the quote says on the slide there, Java is to JavaScript as car is to carpet. They are very different things. In fact, JavaScript is actually, I believe it was like a marketing ploy by some people who built a web browser years ago that is no longer used. When they were coming up with a programming language for that web browser, they were like, well, Java's super popular, so let's call it JavaScript. And loads of people want to go and do it. And it essentially was a marketing ploy. But Java's not just a programming language. There is the Java programming language, but Java as a term, Java as a kind of thing that exists, it can also be used to refer to the software platform, i.e. the Java software platform. And this is where Java kind of has some of its sort of uniqueness from things like C++ and more compiled languages. I mean, like, as I will go on to explain about the software platform, you'll figure out that it's actually, compared to modern programming languages, quite similar. But it's quite unique because when you write Java code, you essentially turn that code into, when you run it through a compiler, unlike compiled languages like C and C++, where you turn it into essentially native code that the computer can understand, and then you execute that like native code. Java, you instead turn into bytecode, or Java bytecode specifically. And then this bytecode runs inside of a tiny little program called the JVM, or the Java Virtual Machine. And what that allows Java to be is that essentially any computer that has the capabilities of running a Java virtual machine, provided you install the software to be able to run the Java virtual machine, then you'll be able to run Java. It means that, like, rather than writing stuff in C++, if you want to run it on a machine, you have to compile it for that specific like CPU architecture, maybe even graphical architecture if you're working with a graphics card, or whatever hardware you're working with, rather than you having to write it in a way that is somewhat tailored for the hardware, or at least for the operating system that you're working with. Java is essentially like, well, we want you to be able to just write Java, and then provided that the machine that you're going to run it on also has like Java installed, then you can run it. And for people who have written like Node.js, which is like the JavaScript version of like a proper programming language, it's JavaScript but on computers rather than in the browser, you'll recognize that that concept is pretty similar. If you've got like Node, or if you've got Python installed on a particular machine, then you can run the Node and Python code. But the difference between like Node.js and Python and Java in that regard is that Java has like a pre-compilation step. It turns Java code into bytecode that then runs in the machine. So it's essentially like it's finding the balance between the raw performance of compiling your code to something that is super small and just executes on the machine, and also the benefit of being able to run code that could run anywhere, provided that you have the sort of the runtime environment for it. And so that's where these other things like JIT and JRE extras come in. So the JRE stands for the Java Runtime Environment. And essentially, if a machine has the Java Runtime Environment installed on it, then it can run Java programs. And the Java Runtime Environment you can think of as essentially a JVM plus extra stuff that is required to run Java code. So the JVM is the thing that allows the program to run, but then the Java runtime environment will interface with like the operating system and that sort of stuff to make sure that it can run. JIT stands for just-in-time compilation. So really, I should have written JIT compilation. And just-in-time compilation is what we refer to when we have these sorts of languages that aren't already in native code and they need to be turned into native code before they can be run on the machine. So Python and Node.js, they do just-in-time compilation. They do a sort of a twist on just-in-time compilation, but essentially it's when you come to executing your code just in time, just before the code is actually executed, it turns the code from Node.js or Python or Java bytecode in this case into the native code that it then is able to run on your machine. So that's what, so Java also implements that sort of just-in-time compilation. But because Java is like more than just a programming language, it's a software like platform. The JVM, the Java Virtual Machine, and other aspects of the Java sort of software platform that is available are also used by other programming languages. So other programming languages like Kotlin and Scala, Groovy, and Clojure, they all run on the Java Virtual Machine. So essentially, if a machine has the Java runtime environment installed and has a JVM and has all of these like extras and things, then not only can you run Java code, but you could run Kotlin code or Scala code or Groovy code. So along with just creating a programming language that finds the balance between performative code that runs as compiled code and having code be able to run anywhere, it's also got this platform available that other code can be run on it. And this kind of software platform and the programming language was originally developed by a guy called James Gosling at a company called Sun Microsystems. And then it kind of got taken over just generally by Sun, and James Gosling was obviously part of the team at Sun Microsystems that developed Java into much more of a fully fledged language and software platform. And then a company called Oracle, which is a huge software company, bought Sun and acquired it. And now a lot of the development of the Java platform and Java libraries and the Java programming language is sort of done through funding and by Oracle developers. You don't have to use other Oracle technologies with Java. Java is one of those things. Java is one of those languages and platforms, pieces of software, where it's actually super encouraged for a lot of open source to be used. But yeah, it's one of those things that Oracle funded. In fact, in my opinion, Oracle hasn't actually been great for the Java programming language. They've messed around with licensing and all sorts of stuff. But the open source community that is surrounding Java has done an immensely good job of making sure that Java is still a relevant language today. It's not an ancient old language that archaic software wizards do just develop in. It is a modern, functional, nice language to work in. And I attribute a lot of that to the great work of the open source community. Anyway, so that's what Java is. So why do we use it? Well, it's high level, but it's low level. So just like how there is a balance between this kind of half compiled this bytecode stuff and that's nearly native, and the fact that you need a runtime environment to run it, Java is also high level enough that you can write reasonably like sensible and intuitive code, whilst also being able to do quite low level things like interact with lists and things in different ways, that is more memory efficient, or you can do things that are more CPU efficient. So you're able to do all of the nice, well, not all of, but you're able to do a lot of the nice optimizations and clever little low level things that you would be able to do in a much more lower level language like C. But you're also able to do it in what looks like reasonably plain English, in that it's quite high level. So a lot of people like it because it finds that balance quite well. It's statically typed, so everything is, or like all of your variables and everything has a type, which means that debugging your code and writing your code can often be super clear as to exactly what sort of data you're working with. Which obviously has the disadvantage of you have to define everything of being a type. But technically speaking, there is like dynamic typing with type inference as of Java 10. And I guess I'll mention that the latest version is Java 18. So Java 10, like that came out a while ago. And so dynamic typing was introduced, but it's not really used in Java. Most people who write in Java will just write it as statically typed anyway, because it's a bit more intuitive once you get used to it. There are a huge number of libraries and frameworks available for use as part of Java, notably the Spring framework and all the libraries that are surrounding Spring is massive in the like enterprise and just general like web sector of the software industry that writes Java. So these sorts of libraries and frameworks are like, there is a massive amount of them. So if you want to do something, there is probably a library there to help you or a framework there to help you. And I would say that like the amount of libraries is probably like, if you think of how many Node.js or JavaScript libraries there are on NPM, I can't remember if there's more or less, but I would definitely say that Java is going to give Node.js or JavaScript a run for its money in trying to sort of beat the number of packages and libraries and things that are available. It's also very established in the industry. It's over 20 years old now. In fact, I think it's nearly 30 years old. And as I say, it's like that does make it an old language that like lots of old software is written in Java, but and so it's got somewhat of a negative reputation in that regard. But it's also, especially in recent years, really caught up with a lot of the other modern languages. And it's got a lot of really good features as part of it, and it's very established, and so therefore very well supported. A lot of the design thinking and patterns that you do when you're thinking about building your like data models, or you're thinking about your architecture of your software, can be implemented really efficiently in Java, and that's because it's got this like balance between high level and low level stuff, and this statically typing, that you can really define in very clear terms what your architecture and what your models are for like developing your piece of software. And of course, it's the right ones run anywhere. This is the point that I was making before, in that you can write Java on your machine, compile it to Java bytecode, and any other machine that has the Java runtime environment installed on it, you can run it there. So it's a hugely sort of useful language that could be used in lots of different places. So yeah, it's very, very useful. And that's some of the reasons, or the big reasons of why we use Java. So how it works? Well, I always find how things work, it's best to just look at some code. So I'm going to take you through some of the basics of Java, really. Let's have a look at a basic Hello World application. So this is my little IDE, my integrated development environment on my computer. It's called IntelliJ IDEA. It is probably the de facto Java like IDE editor that exists. It is, yeah, it comes in a community version and an ultimate version. I'm currently running the ultimate version because I pay for it. But if you don't want to pay for it, then you can get the community version and be able to do lots of clever things still with it. So let's have a look at a Hello World application. So we have a bunch of sort of boilerplate extra code. This is one of the criticisms that a lot of people have of Java, is that you have to have like these things like package lines, and everything has to be wrapped up in a class. And there's lots of keywords and things that you have to write if you want to get just writing programs. I really don't mind it. I quite like the structure that comes along with it. But it's people have differing opinions, and that's fine. So to explain what's going on here, package hello.world. So whenever we're writing code in Java, it is really good practice. It's technically not required, I don't think, but it's really good practice to put everything or to put some of your code in a package and to organize your code into packages. So here I have 4 packages, one called abstract types. Technically, I couldn't call the package abstract types, just because abstract is like a word that is saved for another thing in Java. So I had to put this dot between C and T just to get it working. I have a package called concrete types, a package called hello world, a package called syntax, and we'll dive into one of these. And they're all inside of a source folder. And so we packages, I mean, like if you actually look at this package in say if I look at it in a, where's the reveal in Finder? Finding files? No. Oh, open in Finder. If you actually have a look at it, they're basically just folders. So here I've got like my folder source. It's got an abstract types, and it's got all of my like Java files inside of here. So packages are essentially just directories, but then you specify them at the top of your Java file to define where this particular bit of code is defined in. We have classes. I'll get a little more onto what a class is, but it's essentially just like a wrapper around some code. It defines, it's like the blueprints for some code. And then we have public static void main. I'm going to get a little more into what public means, static, and what static means. Void essentially just is meaning that we're not going to be returning anything from this function. And then we've defined a main function and given it some string args. Public static void main is a very standard Java function that exists to essentially be the entry point into your program. If you want to write a program in Java, most likely you will start off with some sort of class, probably called like application or program or start or launcher or something like that. And you'll have a public static void main function or method inside of it, as it's often referred to. So this is some like wrapper code to actually get to the point at where we can start running code. And then system out print line. This is essentially just a code. If you're familiar with JavaScript, this is essentially the same as doing like console log hello world. What it's going to do is it's going to, instead of like in JavaScript where it's going to access the console and log something out, it's going to access the system, it's going to access the print stream out object, and it is going to print a line to the print stream out. And what that tends to do is just output it to the console, to a terminal. So if I run this program now, if I like run hello world main, then my IDE will run it and it will print out hello world. So that's a very simple hello world application in Java. So let's get into some of the more kind of syntax of it. So as I'm sure many of you have written like bits of programming code before, we have if statements. So I've defined a little if class here. I've got a public static void main. I've got my package called syntax, all pretty straightforward, simple stuff. And here's some examples of what if statements look like. They look like basically any other if statement that exists. You say if, you have some brackets, you perform some sort of Boolean operation. So in here, we are picking out an argument, pulling out the first string in this string array, parsing it to be a Boolean, and picking it up. And then it says system out, then it was Boolean true. Then the next one, this next if statement shows off that we can do else if and else. So we're going to do args and get the second string at position 1, index 1, because arrays start at 0. And we're going to do dot contains. So we're going to see if this string contains the string name. And then we'll print out saying the string contains name. If it doesn't contain name, then we'll have a look and see if it contains the string mat. Then we'll print that out. And if it doesn't have name or mat inside of it, then it'll run this bit of code that says string did not contain the things that we were looking for. So if I run this, I'm not going to be providing any arguments to this function. So if I just run it as a plain thing, what we'll probably get is, ooh, we got a exception. Index 0 for bound 0. So that will be because we're providing no arguments. And so it's going, well, I can't get anything out of here that is an argument. So if I instead change this to say true, and I change this and I create a new variable called something equals my name is Matt. And I'll edit this to say something. Okay, and then I'll rerun this. Then we can see that, hey, the Boolean was true because parsing this string of true into a Boolean meant that was true. And we could see that this contains the word Matt, and it didn't contain the word name because contains checks the whole like case sensitivity. It actually checks against that sort of stuff as well. So it'll say, yeah, it did contain Matt, but it did not contain name. So that's if statements. Then if you get into lots of if-else statements, then you'll probably end up wanting to write a switch statement, which is basically like an if statement, but more specific to like, I want to detect this case and this case and this case and this case. So a simple switch statement would look probably something like this. It says switch on this particular variable. Let's say, actually, I'm going to, because we know that already that's going to fail. So I'm going to create one called, I'll just put Matt Smith in there. So if I put something into that, and I change this one also to something. So we're going to do a switch on something, and we'll do, okay, if the case is Matt, then if the case that this something equals Matt, then we're going to do this bit of code and then break out of the switch statement. If it's John, then we'll do this bit of code and break out the switch statement. And if it's none of the above cases, then the default behavior will just do something generic. As you may have seen, this little, my IDE is telling me that I can actually make this a little more efficient by turning it into an enhanced switch. And that's what this looks like below, is essentially, it's a slightly more cleaner version of a switch statement. You don't have to put in all the breaks, and you instead just use like this sort of arrow syntax, where if the case is Matt, then you do, then you run the code. If the case is John, then you do the stuff for John, and if it doesn't match any of the cases, then you run the default behavior. So if I run this, then this should come out saying do something generically, because in both cases, even though my string had Matt Smith, it's looking specifically to see if this something string equals the case, not if it contains it. So that's switch statements. We have for loops. So if you want to do an iterative for loop, then you can do for. We're going to start off with an index of 0. We're going to keep going until the index is less than, we're going to keep going whilst the index is less than or equal to 10. And each time we go through the for loop, we're going to increase the index by 1. And then we just system print out what the index number is. We also have for each loops on arrays. So this args string thing is an array. That's what these square brackets mean. So we are going to iterate through each argument, and that's what args stands for. We're going to iterate through all of the arguments and then print out the argument. And then also, we'll get a little bit more onto types of things like lists. But if you have, like, let's say a list of strings called animals, where we have badger and giraffe and kangaroo, then we can do a for loop like this, where we have a animals list and we do dot for each and then run it through. People who write JavaScript, you will probably recognize this because you can do a similar thing with arrays in JavaScript. So yes, I would note here in Java, an array and a list are two separate things. An array is something that is like a type then suffixed with these square brackets, whereas a list is like a different type of thing. It's a list of a particular type, and they do have special properties in Java and handled slightly differently. And essentially, like, whichever one you want to pick depends on the code that you're writing. Arrays are more efficient for if you just want to pick out individual objects at any particular time by the index, whereas things like looping through lists and manipulating objects as a general collection of things is much easier to do as a list rather than as an array. You get essentially more options available to you if you made it a list. The downside of using lists is, as far as I'm aware, it's a bit more like requires a bit more memory in your machine. So if you want to write really highly optimized, low memory usage code, then you might want to opt for arrays more of the time. Or if you're going to be using lists, you want to use it sparingly. Okay, so that's a for loop. And then we also have while loops. So we have two sorts of while loops. We have the standard while loop where, let's say we went through each argument and we went, okay, while the count is less than the length of arguments, then we are going to go through and print out each one of the arguments because it's just a string. And then each time we go through, we're going to increase the count by 1. And eventually, assuming there isn't infinite numbers of arguments, we will go through all of the arguments and print them out. We also have a do while loop, which in this case, it's doing exactly the same thing. We set the count to 0 and we say, I want to do this particular thing whilst this is true. And it's essentially two different ways of writing the same thing. If you wanted to, if you want to pick specific one, I would say the while something is true, then run this code is probably more common. But it depends on the sort of code that you're writing. Sometimes when you're reading through code, it's much more intuitive to write it using the do while syntax than the standard while syntax. Anyway, so those are some of the basic syntax sort of things to get you used to the Java programming language. Let's have a look at some concrete types. So if you're used to JavaScript or if you're used to Python, then you're probably used to just defining a thing by saying var or const or let. I should write const like that, or let. So let's say var thingy equals, and then some like string, or maybe it's a number, or maybe it's a decimal number, or maybe it's an object of some things, and you like build it up like that. If you're used to like JavaScript or Python or something like that, and the the notation of that this is a var means that it's dynamically typed. You can essentially put anything into this variable. That's what var stands for, variable. But the type of the thing that you're putting in is more defined by the data that you're putting in. So if it's a string, then it's just a string, and you can see that it's a string by the quotes, or you can see it's a number by the fact that it's a number, or a decimal by the fact that it's a decimal. But the disadvantage of doing it this way is that you often don't know what sort of data you're working with. And you might want to do some really clever things, or you just want to have a lot of safety in your programming language, or you just want to do, or you just want to the actions that you're performing are actually possible with the variables that you're doing. And that's where statically typed things, and that's where concrete types come into play. So there are some standard concrete types that are available in Java. There are Booleans. There are primitive Booleans where you can say, I'm going to define a Boolean and this is my variable name and it's going to be set to true. Or you can define an object Boolean, which is Boolean with a big B, and set that to true. The difference here between a primitive type and a Boolean type is essentially that the primitive type is going to be much smaller. It's going to have a memory, like the amount of memory that it's going to be taking up is tiny. I think in the case of the Boolean variable, it only takes up like 1 bit of memory, i.e. like one single, like 0 or 1 in memory. Whereas a object Boolean is going to take up a lot more memory. I think it's like 4 bytes or something. But the advantage of using an object Boolean is that you get to do more with it. So if I tried to do my primitive Boolean and then did dot and had a look at the functions and things that are available, I mean, there's like all of these sorts of things, but this is more like IntelliJ, my IDE, telling me of clever things that I can do with it. It's not actual functions on the variable itself. But if I do my object Boolean and press dot, I can get the Boolean value as an actual primitive Boolean. I can compare it to another Boolean. I can describe the constable, whatever that means. I could turn it into a string. I could do an equals comparison on it. I could do some sort of weight method on it. There's like a bunch more that I could do with this particular object if it is of a type object with the programming language. But in return, I have to sacrifice more memory to be able to do those things. There are also decimals. Actually, we'll deal with whole numbers first. So likewise with whole numbers, so like integers, then we have primitive integers and object integers, pretty much exactly the same as Booleans. Like the primitive one uses less memory, but you can do less with it. The object type uses more memory, but you can do more with it. And there's integers there. And then longs, rather than integers, essentially take up even more memory than the primitive and object versions of integer. And so they are really useful for defining big numbers. And when I say big numbers, I'm meaning much bigger than 100,000. It's usually in the millions and things. So if you want to store, I don't know, Jeff Bezos's like value or something, how much he earns, how much he's earned over his lifetime, that's going to be in the trillions. And so you'd probably want to store that number in a long rather than an integer. And so it's just down to the case-by-case basis of when you would want to use those. Sticking with numbers, let's talk about decimals. We also have floats. So a float and a double. A float is essentially saying I want to define a decimal number. It comes from the term floating point number. If you want to be interested in more about floating point numbers, I highly recommend you go and just Google it. I could spend the next hour talking about floating point numbers, and that's not what this is for. We're going to be talking about Java. So floats are essentially for defining decimal numbers. Again, primitive and object types are available, and doubles are basically exactly the same as floats. You don't have to put in the subsequent F. I think you might actually be able to just put in a D rather than an F, but you can also just exclude the D if you wanted to. And the difference between a float and a double is just like how an integer and a long, an integer is for like normal whole numbers and long is for really big whole numbers. Well, a float is for normal decimal numbers and a double is for much higher precision decimal numbers. So if you have a decimal number like pi that goes on infinitely and you want to be as accurate as possible with that particular value, you might want to use a double, or you might want to define your own type that contains even more precision. But usually most of the time a float or a double is good enough. So a double essentially just uses more memory to store a much more accurate version of that floating point number. And finally, strings. We have strings. Like pretty much anyone who's ever had any experience with a programming language is used to strings. They are like character sequences of letters wrapped up in quotes. In Java, we tend to do that in double quotes. I think you technically can use single quotes, but if you want to do actually, no, you can't do single quotes. I'm pretty sure you have to do double quotes. And if you want to use single quotes, that is for single characters, and that's a slightly different type. So if you want to write Java code, you've got to use double quotes for strings anyway. And then strings have loads of methods available. So you can turn them in, like, that are already built into the language. So you can turn them into lowercase, uppercase, you can check contains, you can check equals, you can check ends with, you can check the length, you can replace things in the string, you can grab out substrings, all the standard stuff that you are used to from any other programming language. And each one of these things outputs a variable that is of a particular type. And so I know that a string contains Matt, this particular thing is going to output a Boolean of whether it contains the string Matt or not. So this is where like a lot of the power of static typing comes in, is the fact that I understand that this is a Boolean now, and I'm not going to be doing I'm not going to try and do some weird thing with a string or with an object. I just know it's a Boolean and I can treat it as a Boolean. And if I don't treat it as a Boolean, then it won't compile. And that's good because I'm being stupid with the language if I'm trying to get it to compile. So that's concrete types. And then finally, we have abstract types. So if you want to go and create your own types, like strings or some other sort of data, then you have these things called abstract types that you can use to work with them. The first abstract type is a class. So if we have a look at this, we have a class. You might notice it's not got public at the beginning of it. That doesn't really matter right now. But the point is, it's got some class. And we've called this class some data class because it's going to contain some data. That's what it is. And a class essentially is just a blueprint for what an object could look like. So let's say later on down here, I want to define my own variable of type some data class. Well, I'm going to create a new one called some data class and create it with some data. And then now that I got the variable, I can then perform functions on it. So these things here, that like this thing here where I've got a thingy, this is an object, and the some data class is it's a type, it's a class, it's a blueprint for what some data could look like. So inside of classes, you will have properties. So you'll have things where you've got private properties, protected properties, default properties, and public properties. This is where I'm going to talk a little bit about what this whole public, private, protected stuff means, or if you just omit it, what that means. So a private property or a private class or whatever essentially means that you are only going to be using it within this class or even just within this file. It is going to be completely private. Protected is slightly more lax with those permissions. You can essentially use it anywhere within this particular package. So if I want to use protected string, I can, if I've got an object of some data class, then I can access this protected string as long as I am within this package. Meaning that the rest of the world who maybe use my code aren't going to be able to gain access to this string because it is protected. The default version, which is when you just emit it, is very much like protected, but it also allows people who base their code off of some data class to be able to access the default string. And so you don't necessarily need to be in the same package for that, but you do at the very least need to be like inheriting and like extending your behavior from this particular class. We'll get a little bit more into inheritance in a minute. And then public is essentially, you can do what you want with it. It is publicly available. If I made this code available on the internet as a package, then people who used the class some data class could access the public string and do whatever they wanted with it and set it to whatever they wanted and fetch out whatever they wanted. It is a public variable. And so these are super useful for when you're trying to build up packages of code and making and sharing them with other developers. And you want to make sure that the things that should be available to those developers are available, and the things that shouldn't be available to the developer or shouldn't be available to other packages in your library aren't available. And so that's what these things are called. This kind of collection of properties and the term for this sort of permission system that we have built in is called encapsulation. And you can read a lot more about it some other time. We also have static properties. So static properties essentially means that if you want to access it, you don't need to create an object from this class. You can just reference the class and then get the string. Likewise down here, where I just do some data.class dot static thing. You don't need to create an object of type some data class. You can just reference it directly. We then have constructors. So constructors are, if we have this class as like a blueprint, then the constructor is essentially the function that's going to take the blueprint and produce the object for me. So if I have blueprints of a house, maybe some data class defines the blueprints for a house. The constructor is like the construction worker who is going to actually look at these blueprints and build me a house according to the blueprints. In Java, you can have multiple constructors per class. So here we have 3. We have a very basic constructor where it doesn't take any arguments and just sets all of the strings to just be empty strings. We have a constructor with a single argument where you can set the private string, and a constructor with 2 arguments where we set the private and the protected string and set everything else as being just empty strings. And you can see down here, I've used the first argument constructor where I set the private string to it me. And so I use this constructor, and that is why this thing is highlighted as being in yellow, because my IDE is telling me that this is being used, whereas this one is currently never used according to my code. And then we have, as part of classes, we have methods. These are essentially functions that are tied to a particular class. So in this case, we have 2 methods, one called getPrivateString that just returns the private string. And we also have setPrivateString that where it takes a string and then sets it. So here in my little application class, I create a object or an instance of type some data class, and I use this constructor. And whenever you use a constructor, you always use the new keyword to be able to create it. And that essentially tells Java to create a little bit of memory and store all of this stuff in a variable and everything like that. And then I'm going to do thingy.getPrivateString to be able to get out the private string and print it out. So even though I have private string as private, I am still able to manipulate it through methods. And that's where a lot of the kind of permissions systems comes in. You can't necessarily directly manipulate private string, but you can manipulate it through methods that are available. So here I'm just pulling it out. So if I run this class application, then it prints out it me because the private string is it me, and then it prints out the static string, which is my static string, because I'm just referencing it statically. So that's classes. We have abstract classes. Abstract classes are for when you have multiple classes that share similar properties. So let's say I have a abstract class of animal, and every animal has legs. Well, technically not every animal has legs, but every animal will have a number of legs, even if that number is 0 in the case of things like snakes. And I've just got a simple constructor here to say when you initialize an animal, it is going to be of type legs. You need to provide me a number of legs, and that's going to set it. And then any animal has a get legs. Now it's an abstract class, which means we can't directly instantiate it. We can't directly construct it. But what we can do is define animals and then extend the abstract class. Now we can technically extend classes that aren't abstract, but in this case, we are extending abstract classes. So here I'm saying I want to create a badger and a badger. When you construct a badger, I want you to call the animal, I want to call the super constructor, which is essentially the constructor of this parent class, I guess is what we could call it, and say that we have 4 legs, whereas the kangaroo only has 2 legs. So what this allows us to do is essentially abstract away some functionality into a much more generic class. So it allows us to do something like this, where we could have a list of animals that could be of kangaroo, badger, and any other animal class that extends the animal abstract class, and then loop through each one of these. And I don't need to know exactly what type of class that these animals all are in. I just need to know that they're all animals. So in this case, I could go through for each animal, get out the animal and get its number of legs and print it out. And so if I run this, I can see that the kangaroo has 2 legs and the badger has 4 legs. And beyond animals, obviously, this would have a huge amount of functionality where if you're wanting to deal with lots of data that all have very similar properties, well, maybe all of these different data are going to be in separate classes, but because they all extend from the same parent class, you can do generic operations on all of it without necessarily needing your code to know about exactly what type your data is. Like we do with this animal example. We have another sort of abstraction called interfaces. And interfaces, if I have a look here, interfaces are very much like abstract classes, except rather than worrying about like properties or being parent classes, interfaces only care about what you do, what operations you can perform. So an interface, for instance, say an interface is called noisemaker. I'm going to say that a noisemaker should have the operation make noise, and it would then return a string. That's what this syntax means. It says string. If I didn't want it to return a string, if I just wanted it to make noise, I could redefine this as being void by saying that it doesn't return anything. It's just going to do something. But in this case, I want it to return a string. And then what we can do here is define multiple things that are noisemakers. I can say that a dog implements a noisemaker, and it's going to override the noisemaker make noise function or method and return the string bark. I'm going to implement, I'm going to put a cat in, and it implements the noisemaker by returning meow. And hey, those two things are animals, but car is also a noisemaker, and it goes vroom. And so what we could do here is we could say that a cat extends an animal. We could also have a dog implements thing. Maybe I need to do it like that. No. Extend an animal. And then in this case, I also need to put in a constructor because the animal constructor has it. So here we now have this model of data where we have dogs and cats that are both animals but also implement noisemaker, and we also have a car that doesn't extend an animal but does also implement noisemaker. And what I can do is it means that I can have a list of things that can make noise and only deal with the things that implement noisemaker. And so I could have a list of things that make noise here, a dog, a cat, a car, and then I could loop them through and say, make the noise. So if I run this function, I can say, okay, it's going to bark, it's going to meow, it's going to vroom for all of the things. And so you can see how if we expand this out into other operations, we could have interfaces of, let's say a simple a class. We could have an interface to say that well, anything that is a web client can make a fetch request to fetch some data from somewhere. And so you could have lots of different classes implement this web client interface to say that well, this particular client fetches data from this location, and this data fetches data from this location. And then if you had multiple web clients, you could like loop them through, or you might not even care what type the web client is. You just care that it is a web client, and then you just run the fetch function. And so this allows us to create a lot more abstraction in our code, and it allows us to essentially not have to deal directly with implementation and directly with the data. We can deal with data as a generic thing, which can be super, super powerful and is used quite a lot in Java. So that's interfaces. Finally, we have enums, and enums are, or enumerations as the full word would be called, but in here we just use the keyword enum to define an enumeration, is essentially a thing that contains some constant values. So here I have an enum called day, and it's got a bunch of values in it called Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, because those are the days of the week. Maybe I will call this enum day of week. And then I want to change this to be day of week, and I'll put this as day of week, and I'll put this as day of week. So here I can say I want an enum of a day of a week, and then I could say get the values of the day of the week, loop through and print out each day, and then also say that today is the day of the week dot Wednesday. And so essentially an enumeration allows us to define constants if we wanted to deal with particular constant values. So if I run this enumeration function, then I get Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday from the for loop, and I get today is Wednesday from today is Wednesday. And so that's, in general, the Java programming language. Now, I've put everything here inside of classes and packages and just all inside of a source folder. But if you don't want to do that, if you want to start building applications and depending on libraries and doing all that sort of stuff, you probably want to use a build tool. So like in Python, there is pip, the build tool, and like in JavaScript, there is npm or yarn or whatever build tool you want to use. In Java, there are two build tools. There is Maven and there is Gradle. I massively prefer Maven over Gradle, and it's a lot simpler in my opinion. So I'm just going to cover Maven today, but do know that Gradle is also available. And so Maven essentially does two things. Number one, you get a pom.xml file, which if you're used to writing JavaScript things is kind of similar to like a package.json file. And a POM file is an XML file where you define some information about your application. The fact that it's called my Maven project, it uses Java version 18. I depend on these libraries of these versions, and I'm going to use it in test. And to build my application, I'm going to compile it and then use the Surefire plugin to run my tests for it. And then Maven does the other thing that Maven does, as well as having a POM file, is it forces you into adhering to a very clear, structured directory structure. So you have you have a folder called source, and inside of source you have a main and a test folder. Your main folder contains all of your actual code and things that you want to be working with. So it contains all of your Java code and all of your resource files in case you want to work with some resources. And then your test folder contains all of your test code that you use to actually test your code is working properly. So let's say I have an application in here. It's of public class application. It does a public static void main. It prints out hello world. It creates two people or person into a list called Brittany Villegas and Matt Smith. And we're going to loop through the person list and print them out. And then the person here is defined as a person. You have a forename, a surname. You can create a person like that. And then when you do get name, it's just going to concatenate these two together. So if I run this application, it's just going to print out hello world, Brittany Villegas, Matt Smith. And then my tests I use here. So Java comes, well, Java not comes with, but Java, the standard testing sort of framework and library that people use to test Java code is called JUnit. And it's for, if you're familiar with the term unit testing, it is for unit testing JUnit for Java, hence JUnit, Java unit testing. And so it's kind of like Jest or like any other testing framework library that you've used before. I will define a test. I want my test is called get name is formatted correctly. So I'm going to define a name, create a person, and check and assert that what I should be getting is a forename and a surname delimited by a space. And then if I do test person.getName, so I can run this test, and in my IDE, I can see that my tests pass. So this is another one of the things that I really like about Java is that its support for doing testing is so good. I honestly have not found a better way of doing testing in any other language. Like JavaScript has like the kind of jest, and it's all very the JUnit offers as part of the Java programming language or as part of just testing Java is the best that I've ever seen. And it's part of the reason why I really like writing stuff in Java. And so then when you run, is it bundles all of your classes and your things that are related to your application into a target directory, which usually I just completely ignore because it's basically where all the compiled stuff lives. And so that's Maven. That is like the sort of one of the standard build systems of writing Java. You write all of your code in main Java, and you handle all of your dependencies and things in pom.xml. So that's how it all works. That's how Java works. Let's move on because we're short on time. Ooh, I'm running 5 minutes over, so I'll finish up super quick. So where and when can we use it? So there is various different like sort of platforms of Java that you can use. There is Java Card, which is used for smart cards and really low memory devices. So if you've got like a contactless card that's got like a tiny little chip on it, well, if you wanted to write a Java application that could run on that card, you would probably want to use the Java Card edition of Java to be able to write stuff for that. There is Java Micro Edition for writing things for like Internet of Things devices or small little devices that like sensors and tiny little embedded things, and to some extent mobile applications, but not really, because Android and like the systems that are built into Android and iOS and things tend to be used instead of the Java Micro Edition stuff. There is the Java Standard Edition, which is basically what I've shown all of you today, is most of the things that's just in the Standard Edition. That is used for creating desktop applications and general programs and to some extent games, because Minecraft was originally written in Java, and I'm pretty sure that just used the Standard Edition. And then there is the Jakarta Enterprise Edition. It's called Jakarta because of, again, Oracle, the people who do a bunch of development stuff with Java, had trademarks and things involved on the word Java. So like some of the people who were trying to standardize the enterprise version of Java had to call it Jakarta because Oracle were being knobheads or something like that. That's my understanding of it anyway. But the Enterprise Edition is essentially the stuff where you want to develop web applications and server-side applications and all of that sort of clever stuff. All is part of the Enterprise Edition. And essentially that just means like the sort of libraries and things that are built into Java, the things that are available to you in the Java environment, is like slightly smaller or bigger depending on the edition that you're using. And also you can write Android applications in Java, but it's not really used as much anymore. Google went heavy into Java initially, but they've diverted away into Kotlin. So it still uses the Java virtual machine and it still is interoperable with Java. But if you want to write Android apps nowadays natively, then you probably want to write it in Kotlin. If you want to learn more and get started with Java, I recommend downloading the Java Development Kit or the JDK. Use a program called SDKman to do that because it's super easy to manage the versions of Java that you have installed on your machine. The latest version is Java 18. The LTS or the long-term support version is Java 17. You might as well just use 18 though. It's the latest one. I highly recommend using IntelliJ IDE. As I mentioned before, it's the standard one. You could use another IDE like Eclipse, but I wouldn't recommend it. If you want to look at documentation on Java and look at more into the Java programming language, you can go to dev.java. And if you want to if you want to use a specific version of a Java development kit, I recommend you check out adoptium.net for an open source version, because as I mentioned before, Oracle is nasty and like kind of ruin a lot of things with licensing. I much prefer and highly recommend people stick to the open source stuff, and adoptium.net is really the center point for a lot of the open source JDK related things. If you want to get started with Spring and making your life substantially easier, writing Java code with loads of pre-built stuff and loads of libraries and functionality that is just pre-written for you, I highly recommend checking out spring.io and looking at the libraries and the Spring framework that is available there. And if you want to develop Android apps, then I recommend you download Android Studio instead of IntelliJ IDEA, and develop some Android stuff using Android Studio. It's actually based on IntelliJ IDEA. Yeah, you'll be familiar with things there. Are there any questions? So I will now exit out of here and have a look in the chat here. I'm going to stop sharing and we'll answer the questions that we've got. So Aswin, do we have more packages for Java with Spring than Node.js, NPM? If we're a student, IntelliJ IDE provides free access to Ultimate version, which is really cool. Sweet, yes. So if you're a student, get Ultimate access. It's super good. Do we have more packages for Java with Spring than Node.js? I don't know. You probably have to Google it. I'll make my video appear again and talk here. Hello, I'm still here. So yeah, I don't know. I can't remember which has more, but I suspect. Hey Nelson, big thumbs up. I can't remember, but we probably have about the same or slightly less. String methods in Java, some of the syntax looks like PHP. I can totally see that. And yeah, I mean, programming languages in general look a lot like each other. So interfaces are only for methods. Yes. When you define an interface, you only define the methods that you would like classes that implement that interface to use. We only ever care about operations. Aswin, you already got there ahead of me. Yes, interfaces are used to add methods and abstract classes for both data types and methods. Thank you very much, Aswin. And does JUnit similar to assertion libraries in Python? Yes, there is an assertion library as part of JUnit that is very similar to the Python assertion libraries that are available there. So yes, the assertion libraries are very similar. And is Java card for like Metro cards or RFID card types? It's generally for like smart cards. So if you have like there are many governments that issue like ID cards that have like chips and things built into them, which are like, I think, RFID cards that have like a little bit of code that run if they're being scanned, or if you plug them into somewhere, then there's a bit of code that maybe will run. And that's what the Java card stuff is related to. So yeah, hopefully that's helpful. Do we have any other questions or queries or worries or woes about Java or where to go and get started?
Just a comment. A very nice presentation. Learning about Java. It was not so scary as I thought.
Yeah.
Yeah.
It's actually quite a once you kind of get used to some of the syntax, it's fairly easy to dive in. And yeah, a lot of the object-oriented stuff and the class-based stuff is once you kind of get around the concept, it can be fairly intuitive, or at least I find it to be. So I'm glad you
Yeah,
found the same.
I can see that is pretty based on object oriented programming. It's
Yes.
like there are just one thing, Java and
Yeah,
object oriented.
it's very object oriented and class based. There is like lots of functional things. So if you dive more into Java, I didn't go into it today, but if you dive more into Java, there are things like the streams library and other aspects of the Java programming language that's been introduced in more recent revisions, where languages like Node.js and other sort of functional programming concepts have then been introduced into the Java language to essentially modernize it and bring a lot of the power of functional programming into Java. It's still very heavily class-based and object-oriented based. Granted, a lot of the world can be thought of in object-oriented programming, and it's quite easy to think about things as objects. But if you want to then do stuff in a functional way, there are a fair few systems now built into Java that allow you to do functional things. But if you wanted to go pure functional, I would highly recommend not writing it in Java. And if you wanted a similar experience writing functional code to writing stuff in Java, like object-oriented code, I would highly recommend you check out Scala, which is a functional programming language based on the Java virtual machine. If you don't like Scala, I recommend you check out Haskell, as that is like when I did a bit of functional programming stuff in university and then for some personal projects, I really liked the way that Haskell worked because it operated in a very like strict manner and gave me a lot of structure and help in the same way that Java does.
Yeah, so
Um,
does both of them use JVM, right?
No,
Scala as well.
Scala uses JVM. Haskell is a completely separate thing. There are similarities between like Haskell and Scala and Haskell and Java in terms of like syntax, in the sense that they both use types. They both have a lot of um, like a lot of functions and functionality like built into the language. But Haskell is a very different thing to like Scala or Java. It doesn't use JVM at all. Yeah. Any other questions or queries?
Yeah, so actually I learned Java till those core skill like subjects, right? Like Lambda expression, stream APIs. So
Mm-hmm.
if we want to go beyond that, should I like try out Spring framework? And
I would highly recommend you check out the Spring framework.
Okay.
And if you wanted to go further than doing like Stream, than using like the Stream API, or just like using more advanced things, I would check out dev.java and have a look at some of the documentation. I would check out the Spring framework and Spring library stuff to check out what you can do with Spring to maybe inspire you on some ideas. But generally, I'd just say try and think of a problem that you want to solve, or a thing that you want to create, and then try writing it in Java. And when you come across a problem, like let's say you want to read over some structured data, or like from a database, or you want to process things in multiple threads, like essentially doing things concurrently, then Google it. And there are loads of libraries involved. Spring helps a lot with doing more advanced things like concurrency and like dealing with databases and that sort of stuff. It provides a lot of help with those sorts of common tasks. And as you start to develop more knowledge around like patterns and architecture, you'll find that a lot of that stuff aligns a lot with what Spring makes available, which is why it's become such a hugely popular framework and set of libraries. So yeah, that's what I recommend.
Cool.
Okay, I've already run over by like 18 minutes, but hopefully, yeah, well, given the reactions, I'm glad I did. So yeah, I'll stop this recording and I'll liaise with Brittany and get this up onto YouTube as well, so you can watch it back if you ever want to. But otherwise, I hope you all have a great rest of your night, and I'll see you next time.
Yes,
Right.
you.
Okay.
It was a great
Thank you
event,
much.
actually. Even I got
Thanks.
to learn few new
Bye-bye.
things as well.
Awesome. I'm so glad to hear that.
Very nice.
Bye.